Welcome to Ask and Learn.
So we have 4 metal plates, each with an area of 7.5 square centimeters, which, when converted to square meters, is 7.5 times 10 to the minus 4. And the separation distance is the same between any pair of them. It's 1.19 millimeters, which is 1.19 times 10 to the minus 3 meters. So first of all, we're connecting plates 1, 2, and 3. And since we have 3 plates, that's going to form 2 capacitors, one with plate 1 and 2, and one with plate 2 and 3. So we have a battery of 12 volts, and plates 1 and 3 are both connected to the negative terminal, and plate 2 is connected to the positive terminal. So this is plate 2, and this is also plate 2. It's not 2 different plates, it's just they're 2 different capacitors. So this is the same plate that's contributing to 2 different capacitors. Those are plates 1 and 3. And so the capacitance of either one of these capacitors is going to be the area times epsilon naught over the separation distance, which is 7.5 times 10 to the minus 4 times 8.85 times 10 to the minus 12 divided by 1.19 times 10 to the minus 3, which is 5.58 times 10 to the minus 12. Now the equivalent capacitance for this circuit, well, there are 2 capacitors connected in parallel, so that's just the sum of the 2, so 2C, which is 1.12 times 10 to the minus 11. And now the charge on plate 2, well, the charge on either capacitor is the capacitance times the voltage, and the voltage is the same across either capacitor because they're in parallel. However, plate 2 is in both capacitors, so the charge on plate 2 is going to be twice the charge on either capacitor. So this is 2 times 5.58 times 10 to the minus 12 times 12 volts, which is 1.34 times 10 to the minus 10. And now what happens if we attach the 4th plate as well? So now we have the battery. Okay, so plates 1 and 3 are both connected to the negative terminal, and plates 2 and 4 are connected to the positive terminal, so that's plate 2, that's also plate 2. This is plate 4, and then we need another plate 3, so these are both plate 3, this is plate 4, these are both plate 2, and this is plate 1. So now, what do we want? The equivalent capacitance? Yeah, okay. So the equivalent capacitance of this, well, we have 3 capacitors now. So it's just going to be C plus C plus C, which is 3C. And that's 1.67 times 10 to the minus 11. Now, we want to find the charge on plate 4. So unlike plate 2, plate 4 is only in one capacitor. So we don't need to double the charge. So the charge on plate 4 is going to be the capacitance of this capacitor, C, times the voltage, which again is 12 volts because it's the same across any 3 of the branches, which is 6.7 times 10 to the minus 11. So this is in farads, and this is in coulombs. This is in coulombs. This is in farads.